In this video, we're going to learn how to use properties of inverse functions to find exact values of certain composite functions. Now, there's a few range issues that we talked about in the last video on finding the exact value of inverse trigonometric functions that we still have to abide to even here. So what's nice about inverse functions is that they do cancel out and you're just left with the inside angle, but with a certain condition. Here, the sine inverse function cannot yield any angles outside of this negative 90 degree to 90 degree range. So I have to keep that in mind with the x values I'm using. And same thing here is the sine inverse function also has a limit to what values you can plug into it. So if it's outside that range, it's going to be deemed undefined. And I put these all down as a little reminder so you can get yourself reacclimated with what their domains and ranges are. We'll start with the very first one, sine inverse of sine of pi over 8. We just need to make sure that this pi over 8 is within the range of negative pi over 2 to pi over 2, and then we'll be good just to say that sines cancel and the answer is pi over 8. So pi over 8 exists about right here, which is clearly between negative pi over 2 and pi over 2. So I can say the sines cancel, and I get pi over 8. That's using the property of inverse functions canceling out and giving you the inside angle, as long as you're obeying those domains and ranges. The next example, we have sine inverse of sine of 5 pi over 8. So we're trying to double check to see if it's within that range. Now 5 pi over 8 exists right here on the unit circle, which is not within that negative pi over 2 to pi over 2 range. So what we have to do here is find an equivalent y value angle in the first quadrant so that we can replace this 5 pi over 8 with an equivalent value. So again, sine of 5 pi over 8, as long as it's still the same y value in here, it doesn't matter for the inverse function. So to find that angle right there, I see that it goes up 3 pi over 8 from pi, because again, pi can also be written as 8 pi over 8. So I can see that this distance here is 3 pi over 8, so that distance should also be 3 pi over 8 from 0, giving me 3 pi over 8. So perfect. This angle here at 3 pi over 8 is the same y value, so I can rewrite this expression as sine inverse of sine of 3 pi over 8, and it shouldn't change the value at all since both sine of 5 pi over 8 and sine of 3 pi over 8 should yield the same y value between the two. So now that I have an angle that's within my domain, I can now cancel out the signs and say my answer is 3 pi over 8. Let's try another example. We have sine of sine inverse of 0.5. In this case, we reverse the order, meaning that we're just more worried about what we're plugging into the sine inverse function first. And since that is between negative 1 and 1, the signs cancel. The answer is 0.5. It's a very quick response. Next up, we have sine of sine inverse of 1.8. Now, 1.8 is bigger than 1. Again, since we're looking at that sine inverse first, we need to make sure that this number is between negative 1 and 1, but it's clearly not. So this will be not defined. Now let's talk about cosine. So we have sine, a cosine inverse of cosine of negative 2 pi over 3. So let's see where negative 2 pi over 3 is. It would be a clockwise rotation. So right here, 2 pi over 3, negative 2 pi over 3. And we'll see that this angle does not exist between 0 and pi, which is necessary for cosine inverse. So I need to find an equivalent angle in the second quadrant, looks like, to keep the same x value. So if I rotated negative 2 pi over 3 to the left, I could, clockwise, I can also rotate negative 2 pi over 3 counterclockwise to get this angle over here. Give me cosine inverse of cosine of 2 pi over 3. You can also use the even-odd property of cosine to be like, oh, okay, I can also eliminate the negative because it is an even function. But now that I have an angle that's within the range of cosine inverse, I can now just say the answer is 2 pi over 3. Next up, we have cosine of cosine inverse of pi, which is very misleading. You would think, okay, pi is in the range of cosine inverse, but now that I've reversed the order of these, I'm not worried about pi being in the range of cosine inverse. Just is it in its domain? Meaning, can I plug in pi into cosine inverse? Now, pi is about 3.14, which is outside that domain there. So this would not be defined. Be very careful. Always look at how it's ordered. My focus always is look at where's the sine inverse function when dealing with this. And understanding, am I dealing with a domain issue, which means the sine inverse function would come first, or a range issue, meaning the inverse function comes second after the regular trig function. Next up, we have tangent inverse of tangent of 4 pi over 5, which again, tangent inverse is the outer function here, so it becomes second. So I'm looking at, is 4 pi over 5 in the range of tangent inverse? So I'm like, okay. So I'm going to look at the range here. Negative pi over 2 to pi over 2, so I'm somewhere in here. But 4 pi over 5 would be over in this direction. Now, we have to be very careful. Because tangent isn't just the y value, using this angle over here at the same y height would not be an equivalent angle for tangent. Because tangent in the second quadrant is negative, so I need to get another negative angle. Or I need to get another negative tangent value would actually be straight across from it. So a clever trick you can do with tangent is if you have your angle, take a straight edge through the center of your circle and go straight across. And this angle over here, whatever it is, would have the opposite x and y value. So if this was a negative x and a positive y in the second quadrant, now it's a positive x and a negative y, but the same value for each of them, like in terms of magnitude. So now I'm not looking for this angle. I'm like, what is this angle down here? What is this rotation? And one thing that could help is to find this angle, which straight across would be, this is about, again, pi is like 5 pi over 5. So this is about pi over 5 away from the x-axis here. So this angle would also be pi over 5 away from the x-axis. And now if I'm rotating up pi over 5, this angle would be rotating down pi over 5, which would be negative pi over 5. And I'm like, okay, this is the angle I'm more concerned about to make sure this tangent value remains the same. Give me tangent inverse of tangent of negative pi over 5. Which now I can cancel it out because that is within my range. To give me negative pi over 5. And lastly, I want to talk about tangent or tangent inverse of negative 2. In the sine and cosine cases, that would have been undefined. But now tangent's domain for the inverse function is negative infinity to infinity. It means I can use any value I want to as long as it's a real number. So those will just cancel. My answer would be negative 2. So in this case, you should never have an issue with whatever your input number is. And that is how you use properties of inverse functions to find the exact values of certain composite functions.